Hello everyone, I'm Natarajan from Rhodes University. I'm here to give you an overview of how the Event Horizon Telescope captured the very first image of a supermassive black hole. The Event Horizon Telescope Consortium has 13 stakeholder institutions, as you see on the screen, and dozens of affiliated institutions from around the world, including Rhodes University, University of Pretoria, and the South African Radio Astronomy Observatory. This photograph was taken at the EST meeting held in November 2018 at Radboud University in the Netherlands. Many more people than shown in this picture were instrumental in making the black hole image a reality, with the collaboration consisting of more than 200 scientists located internationally. Black holes are a direct prediction of Albert Einstein's general theory of relativity. This image shows what goes on around a black hole. At the center of the black hole is a singularity, where matter has collapsed into a point of infinite density where the currently known laws of physics break down. The radius around the singularity, at which matter and energy traveling towards the black hole cannot escape its gravity, is called the event horizon. Although not even light can escape it, just outside the event horizon, the photons emitted from the hot plasma in jets or the accretion disk are bent round so that a photon sphere is formed around a dark shadow. This ring and the shadow are what we see in the now famous image of the supermassive black hole at the center of the giant elliptical galaxy M87, observed by EST in April 2017. This supermassive black hole is so big that it dwarfs our entire solar system. But located at a distance of 53.5 million light years from the Earth, this black hole is 46 million times smaller than the moon in our night sky. How do we image something that appears this small? The answer lies in what is called the angular resolution of a telescope. The larger a telescope and the shorter the wavelength of observation, the finer are the details that we can see. At radio wavelengths, we need a telescope the size of the Earth to capture these details. The Event Horizon Telescope is a global network of radio telescopes that uses a technique called very long baseline interferometry, which combines the data from radio antennas from around the world in a way that a telescope of Earth size is created. These pictures show the extreme conditions that are experienced at various observing sites of the EST. Telescopes located in Hawaii, Spain, Chile, and the South Pole, among others, participated in the EST observations of 2017. In VLBI, the signals arriving at various telescopes are recorded on hard disks and flown to central processing facilities. These facilities then calibrate the data, which enables the detection of weak signals hiding in the noise, from which the final image can be created. So how does this imaging happen? Scientists are normal people with beliefs and prejudices that influence what they see. To combat these biases, 4 teams worked independently on creating images from the data, with different algorithms and assumptions going into the imaging process. Then, in stage 2, 3 different imaging algorithms were used to create images from these data, as shown here. In both stages, a photon ring of a size consistent with the shadow of a supermassive black hole with a mass of 6.5 billion suns was observed. Also, synthetic data were generated based on theoretical models of black holes and realistic weather conditions at the telescope sites during actual observations. Images reconstructed from these synthetic data were also consistent with the images obtained with actual data. Where do we go next from here? The supermassive black hole Sagittarius A star, located at the center of the Milky Way, is a fast-rotating black hole that changes its structure every few minutes. The collaboration is aiming to create movies of such black holes for capturing this rotation. More telescopes added to the EST, as shown in the bottom panel, will enable us to study the finer details in the rings as well. What we have seen is only the beginning. You can find more details on the status of EST on its official website, eventhorizontelescope.org. Thank you and stay safe.